So once we've actually determined that two inverses or two matrices are inverses of one another, so that's what we just did in this example. We found that this matrix was the inverse to our coefficient matrix because it equaled this identity matrix of the 1, 1, 1 diagonal. So we're going to use that inverse matrix to solve that matrix equation that we started with. So like on the very beginning of the notes of this section, we wrote that matrix equation, coefficients times your variables equals whatever your equation equals. We're going to solve this equation now using the inverse. We can't divide by matrices. So this matrix is being multiplied by xyz. We can't just like undo matrix multiplication. It doesn't work that way. So to undo it or kind of get the xyz by itself, we multiply by the inverse. And remember, so the inverse is just noted with that little -1. So we are multiplying the inverse to both sides of the equation. So when we do that on the left side, they equal that identity matrix and they leave us with 1x, 1y, 1z. So on the left-hand side, that 1x, 1y, 1z is what this is representing right here. On the right-hand side, however, we need to figure out what that actually is. So like, yes, we're multiplying both sides by the identity matrix or the inverse matrix, but we actually have to figure out what it is over here on the right-hand side. So it just kind of keeps going down. And then that last step is going to be actually solving for this. So just as a refresher, the inverse is a 3 by 3 matrix. This guy is a 3 by 1. So your new matrix should be a 3 by 1. I'm just going to write big spaces here so I have room to work. So remember row times column. So 7 times 2, 14. -3 times -3 is 9. -3 times 4 is -12. Then your next row, -1 times 2. -2. 1 times -3. 0 times 4. And your last row. -1 times 2. 0 times -3. 1 times 4. So 14 plus 9 is 23. Minus 12 gives you guys 11 for x. Then -2 and -3 is -5 for y. -2 plus 4 is 2 for z. So your ordered triple, or your solution, is 11, -5, 2. So when we are actually going through the process of solving this step right here is what you guys will have to actually show. So whatever your variables are, you'll set them equal to the inverse times that 3 by 1 matrix that your equation is equal. So I kind of also put it down below here. So the most important thing to remember, this is how you solve a systems of equations. You're setting your variables, x, y, z, equal to the inverse matrix times that 3 by 1 matrix that your equation is equal, the values that your equation is equal. That is how you're solving a systems of equation. System of equations. So when you guys are doing this, it will most likely actually give you the inverse, and then you will use that to go about solving.